Okay, now that we know how to execute a kernel with one work item, let's look at how to do it with a very large array. Okay, so I'm going to create a new project. I'll call this process array. Similar things to what we've been doing, a console application, empty project. Now, I'm going to need this for pretty much the rest of my tutorial series. So what I'm gonna do is actually put that in yet another project and then share those with all my current projects. So let's call it OpenCL Helper. I want this to be let's make it a static library for simplicity. And create a header file, OpenCL Helper. Paste this code in. And this is going to return a program, so I need to include cl.clh. It's not resolving it because I need to add the property sheet that I've added before. OpenCL Helper. But I also need to make it 64-bit. Configuration manager. I'll do it for both of these. 64, yep. New 64. Let's build them all for the hell of it. Okay, that. Add the property sheet. And I will do the same here. Okay, so now this is going to return a platform. Why are you resolving, you bastard? Okay, it's because I wasn't including the C++ one. I would have noticed that if IntelliSense was working. Alright, so I'm going to return a platform, call this create platform, and it's going to pass in the name of the file, so file, place U, that's probably always, oh, an included string. Probably need to include file stream. Anything else? No. What? CL Pro. Oh, that's not platform, program, sorry. Create program. Yeah, that looks okay. Let me just confirm by using it in here. So I need to program. I also first need to include this other project as a reference. So OpenCL Helper, and I will also need to create a header file so that I can get the function prototypes. OpenCL Helper header file. I'll just copy this. Yeah. CL HPP. I'll make sure I want the C++ one. Okay, so it should be able to find it. Create program. No, because I need to add it, of course. What I'll also do is with this property sheet, add the include. That should be it. OpenCL Helper. Yeah, that'll do. It's referencing my PC, but that'll be fine. OpenCL Helper. Cool. File this, what was it? Hello world.cl. Okay, so I need a context, and you can get this from the program using program.getInfo. So I want CL program. No, I don't know. Context, yeah. So remember, whatever you're searching for, because I'm on the program, it will begin with CL program. That's how you end up finding most of these things. And then I also need a device, because I can't resolve this. And I think it only gives me a list of all the devices. I can do context.getInfo. So remember, it's going to be CL context, because I'm dealing with a context object. And devices, there you go. And I know I've got one. I don't know if this needs to be a reference or if I can just copy it. CL device. Oh, fuck off. Nah, doesn't hurt. Error, let's get rid of you. Okay, let me just make sure this still works. So I should, with any luck, see hello world. I do. Awesome. Cool. So that seems to work fine. So now let's start with our new project. Now that we've got all that stuff out the way, so it's going to be process_array.cpp. Alright, so what do I need? To include the OpenCL Helper. After adding it, there's a property sheet. That's added. To add as a reference. Boom. Shakala. And that includes the CL library, so I can just probably just use this. So on int main. Now let's create a program. And we will create a file in a second called processarray.cl. And we will again need the context and device. So I'm just going to do this. Now let's create this new file, processarray.cl. So as before, it needs to start with kernel. I'm just going to name it the same as the file. So what do I want it to do? So it's going to access some global memory. Just make it an int. I'll just say data, and we'll have another one for the out data that we'll modify. So So we won't touch what's coming in, just so we do something a bit different. And so the first thing we'll need is to do get global ID 0, so that we've got the element in this array. And what do we want to do with it? So these will be the same size. So I've got to do the same again here. Get global ID, and this should be square brackets. So I'm just going to multiply whatever's in here by 2. Not in hello world anymore, process array. .cl. Cool. We've got the program now. So we need to create some buffer objects for these. In buff. I've got to create a data first. Let's create a vector of, let's say, I don't know, we'll start off small just to, so it's easy to see what we're doing. And so we need to pass it a context, some memory flags. So we don't want our kernel to be able to modify the array we're passing in, so we'll say clmem read only, and on our side we don't want to be able to modify this array, so we'll say we don't even want to be able to read it again afterwards anyway, so we can say clmem host no access, and what was the other one? Oh yeah, we're passing in something this time, not like in the other time, so you've got to pass in whether you want it to use this directly or you want it to copy. So we want clmem, or an alloc is another one you could use which pins the memory. So it doesn't page it, but it's the slowest one, in my opinion. So we want clmem or copy. Got to pass in the host. No, that's not the one I want. Size. So we want size event multiplied by vec.size, and then the actual vector itself, and then we don't need to worry about the other one. Why don't you like this? No instance of constructor matches the argument list. Okay. Oh, I needed to pass. Can't pass the vector directly. You need to pass a pointer to it, so you just call .data on that. Sort that out. We need an out buffer. So the same sort of arguments. We want it to be able to write only to it. We want to be able to read it. Read only. And don't need the other one. And it's going to be the same size. Not going to pass it the extra argument, because so this means it will only allocate this buffer on the device. We don't need to specifically give it any data, because there'd be no point. It's only going to write to it. So we need to create a kernel now. So we need to pass it the program, the name of the function, or the kernel, sorry, which is just the same as the name of the file, and that's it. And we need to set the arguments, so set arg0 in buff, that you can pass directly, set arg1 out buff, It was complaining at me for a second, but it's gone. So now we need to create a command queue to send some commands to the device, and as always it's context of the device, it's always the same really. Now, previously we used enqueue task, but remember this only executes the kernel once, so we can't use this. You have to use enqueue nd range kernel. So this has only one prototype, and but a few of them are default arguments, so we can ignore quite a few of them for now. So the offset is, so say I only wanted to start this from the 10th element, and I would pass in an offset of 10, but I want to start from the beginning, so I'll pass an offset 0. The global size is pretty much the number of work items you want in total, and it's given a range. Oh, sorry, this shouldn't be 0 because it's a range, no range, which is if you've got multiple dimensions. So say this was you can't use a multi-dimensional vector because they're not contiguous, but if you had a multi-dimensional array and you wanted them to be offset differently, like each dimension, then you'd pass in 2 values for that. So this is the global size, and I want the same amount that's in that vector, so it's vec size. So if I had multiple dimensions, I'd put something else here. As you can see, it's got a constructor with 2 arguments and 3. It doesn't have any more than that, and I think that's because the standard OpenCL specification only says there has to be a minimum of 3. So implementations could have more, but they have to have at least 3. But if you've got more than a 3-dimensional vector, I mean 3-dimensional array, then you're probably doing something wrong in my opinion. So I only need this one. The next one is the local size, so that's how many work items are in a work group. You can leave that at null and let the compiler sort that out for you, which is what I'm going to do in this case, but I'll show you an example later when you wouldn't want it to do that for you, because it can, in the worst case, create 1 work item per work group. And if you remember the graph from a previous video, you want to shove as many work items into work groups as possible. Okay, so this is, we're going to use enqueue read buffer. The other way to do this is to call enqueue map buffer. It's a map buffer, and then do a mem copy and then an unmap. It's supposed to be faster, but it's more steps, and I can't be bothered to do that. But I will probably show you at some point. So we want to read output buffer. Again, it's only got 1 prototype, so it's pretty easy. CL blocking. I will do CL false for now, not GL, CL. And then I'll show you how to make it so that it doesn't execute any further until it's read it. Offset 0. Size, we want size of int multiplied by the size of the vector, and then the pointer, so that's again vec data. Cool. Yeah. So most of it gets a bit confusing because some things want bytes, some things want number of elements. So pretty much these are all bytes, bytes, bytes. The only thing that is a legitimate number is when you're passing it in as a range. What are you complaining about? Get rid of you. Okay. So now if we started to read this vector, it may not have finished writing it back from the device because we passed in false. So this is just, as soon as this is started to execute, it's going to continue to execute our C++ code. And you probably want it to finish before it gets here. But because we're using such a small array, size, it's going to probably finish in time. Probably not, but you know, you don't want to risk it. So what you can do is call CL finish, which makes sure that it's finished executing every command. Or in our queue, we can no, I won't touch that. Okay, so now I think the easiest thing to do is just to debug it, to be honest. Let's see. Auto shit. Okay, I'm going to put a breakpoint here. I'll quickly put one here. Nice, caught it. Okay, so our vector got a bunch of zeros in it. So these have all been default constructed. So it's going to execute our kernel, multiply 0 by 2, and surprise, surprise, it's still 0. So I don't know if my kernel's worked or not, because that's what I expected anyway, but that was also what was already there. So what I need to do is I need to fill this vector. Couple ways to do it. You could just add an extra argument, so it's going to fill all of these with 1, but we'll do it a nice fancier way, and we'll use the fill algorithm. And because I'm doing this because I want to show you a different way of doing it in a sec. So you pass the first end iterator and the value you want. Start with 1. Okay, let's execute this again. So our vector is now full of 1s. Cool. And what was it after? 0. Well, that didn't work, did it? Why didn't you work, you piece of garbage? Or am I the garbage? Alright. Debugging time. So I need to find out what has gone wrong. So let's put a few auto errors. You've got to be careful. Some of these take the error at the end because they return something like like a constructor can't return anything, so it needs to have it at the end. So you've got it up here. So CL enter. Here is can't use this one. Yep. Let's make sure it's set to 0. Set arg. I think that does that return it as well. Yep. Pretty much everything returns it. Get rid of that. Okay. Start from the top. Right. So it created that one fine. Created that one fine. Didn't set that one fine. Minus 48. It's a real bugger trying to find these error codes, but what you can do is this guy has created a nice switch statement which returns you the string version of them. So you see 48 invalid kernel. So our kernel is basically bollocks, is what it's saying. But why is it bollocks? What have I done wrong? Alright, hands up if you spotted it. So if I debug this again, everything looks fine. Got a context, got one device, that's what I said I had before. So So yeah, everything looks fine, except it's not, because I'm just creating a program and passing it the name, when this is in fact calling the program constructor and thinks it's a source file and then creates its own default context. The fuck? Of course, what I needed to do is I wanted to call my create program. Oh, the pain of it all. So yeah, even it's so hard to debug these things. It tries to help you, which just hinders you in the end. Okay, so back to square one. Okay, so error 0, 0. Hooray! Yeah, all good. So we come here. So our vector should be all ones. Yep. So when we go here, it's just to show you, even though we pass blocking as false, it's still not updated them. As soon as I go past finish, bam, update. There you go. Whew, that was painful. Okay, there is one other thing I can show you quickly. Okay, so imagine we had a vector of 100 million, trillion, billion, okay, maybe not that high, but just say it was a really high number. And you wanted to fill that like you are here. So this is still being executed on the CPU. But we can do one better and fill it on the GPU itself in the device. So what I can do, oops, if I could spell, is there's a method on the queue, enqueue fill buffer. There we are. So it takes a buffer, a pattern type, and this is either a scalar or a vector CL type, not the standard vector. It's got to be a CL int, CL int or CL int2 for something like that. But I'm just going to type 1. That will figure it out for me. Offset. Okay, let's have an offset. Screw it. Alright, and it's in bytes, mind, and it's got to be a multiple of the pattern type. The size of the pattern type, I should say. So the size of operator. I won't say 1, I'll say 3. 1's a bit boring. Size of what am I thinking? Oh, size of it times, I don't know, 10. Now this size is from the offset. So it's not the total size of the buffer, it's going to be, other side of the vector, it's going to be vector minus the offset, else you will overflow, probably get an error. No, it's just events, I don't need any of those. So enqueue will read the whole thing. Yep, okay, try that. Alright. So remember, this isn't going to fill this vector here, it's going to fill the buffer on the device. So this will still be loads of zeros. Yep. So I'm hoping that I'm going to fill it with 3s, and then from the 10th element onwards. So the first 10 will be 0. That's the hope anyway. Oh, I didn't check if it succeeded. Soon find out. So I'm hoping the first 10 are zeros, the rest are going to be 6 because we're multiplying them by 2. And they are. Yes. So from 0 to 9, so the 10 elements. Cool. Alright, well that's wraps it up for this video. I think it's gone on long enough.